Welcome to the ArcGIS Maps SDKs for native apps overview and what's new. My name is Rex Hansen. I'm joined by Nick Furness. We're both product managers for native maps SDKs, and we're going to take you through a tour of the native maps SDKs and show you a little bit of what we've done in the last year so you guys can see how we're making progress in this space. I see some familiar faces out there, which is great. So good to see that we're all back in Palm Springs, safe and sound. Great. So one thing just to keep in mind at the beginning, we like to get your feedback on these sessions, certainly about the materials, the flow, and of course any feedback on the products as well. So feel free to share your feedback in the app during or after this session. That'd be great. We like to look through that afterwards and react positively to that. Okay, so first, a brief agenda, just to give you an overview of what we intend to do. So here's what we're going to cover today. And we're going to start by describing the native SDKs, how they sit within the landscape of ArcGIS products and developer tools. And then we're really going to move on to look at the SDKs in more detail. We're going to highlight some recent improvements, and then we'll go to a Q&A section at the end. So first, an introduction, right? So let's just step back and review the native SDKs, really their highlights and their purpose. So first and foremost, the native SDKs are designed for adding mapping, geospatial, and location intelligence capabilities to native apps. Now, the term native here is important because we're using it to differentiate from things like web maps that are built with our JavaScript Maps SDKs or hybrid or web and native technologies. So native apps are compiled using platform core programming languages and APIs, plus our internal native SDK, really our runtime core written in C++. The native apps themselves are delivered using installer technologies, or they're installed on devices via app stores. Another value proposition here is that our native SDKs deliver the best mobile experience, right? Because they're built on underlying platform technologies that help you build apps that are more interactive and more intuitive. So they can take advantage of onboard capabilities such as GPUs or resources like device peripherals and sensors. They can really maximize the available performance on those devices. In addition, the APIs and the SDK resources are designed to provide you, as developers, with really great productive developer experiences that are integrated with your favorite IDEs, from things like VS Code to Xcode. Native SDKs also support multiple platforms for both development and deployment. Hold on, there we go. The native SDKs also power offline workflows, and this is really a critical value prop with our native SDKs. Through access to a variety of different data formats locally on devices, and of course access to services and workflows within the ArcGIS system, we can deliver data and packages for a variety of different offline workflows. So the SDKs offer other offline capabilities besides data access. They're really all designed to deliver a complete 2D and 3D mapping experience offline with local resources and analytics. And of course, the ArcGIS APIs, the Maps SDK, the native Maps SDKs integrate with the ArcGIS system, right? So if you're building full solutions, you're working with a combination of different Esri foundational products and specific capabilities, including things like web maps or web scenes, ArcGIS authentication and identity, and much more. The native SDKs are integrated with the ArcGIS system to provide you with a premium developer experience. Now, one question that comes up fairly frequently is, why build native applications, right? Sometimes we're asked this. Well, there's amazing web technology out there. We deliver amazing web technology today. And you can build some really highly functional, rich web applications that perform great on mobile devices and desktops. Why deal with the extra complexity of building and distributing custom native applications? Well, there's a few reasons for this. And the key one is native applications deliver the best performance. Native Maps SDKs allow you to get closest to the hardware that you're running on, and ultimately will determine the performance that you experience when you're not running within the sandbox of a browser, right? Which is basically limited to the functionality that the browser exposes. So what this does is it gives you access to other native APIs and other SDKs that enable you as a developer, enable us building out the native SDKs to take full advantage of a device and its resources. And this is why any peripherals that might be connected to it can be easily accessed within native environments. So one other notable benefit is the ability to debug fairly advanced scenarios and workflows with rich developer tooling. So we've heard this reported by a number of native developers who've sometimes discovered this the hard way, that we're unable to achieve really that same experience by debugging in a browser. So those rich developer experiences that are provided for native application development. And maybe perhaps the most important benefit, and I highlighted this on the previous slide, is the ability to work offline, disconnected, using local data and analytics. So our JavaScript SDK delivers a great rich API, but it's designed to work online, right? It's designed to work in fully connected environments. The native Maps SDKs are designed to work from the ground up, to work in connected and disconnected modes, online and offline, with full access to local data and resources. So with that in mind, let's take a brief look at the architecture of our native Maps SDKs. So the native Maps SDKs are architected as a set of framework-specific SDKs. They provide a consistent set of APIs based on a common design, concepts, workflows, and capabilities. And we deliver 5 SDKs so that you can choose the development technology that works best for you and the apps that you're building. Now, they share a common C++ core, a common core, that provides really a common set of underlying capabilities. A vast majority of the operational logic and the ability to take advantage and maximize performance and consistency is achieved through our common core, and this is through an implementation that we provide and deliver with all of our SDKs. Now, the 5 SDKs ensure that the C++ core's capabilities are delivered as a 100% natural fit for development environments that you're used to, from programming patterns to package managers to integrated documentation to debugging tools and more. So really the key takeaway here is that this architecture is what the native Maps SDKs use to provide the same capabilities across a variety of different managed languages and frameworks. So this common core is compiled and optimized for individual target platforms for maximum performance in every environment, whether it's a mobile operating system like Android or iOS, or the desktop operating systems like Linux, macOS, or Windows. And we use the appropriate rendering mechanism for the architecture that we're supporting, and we support a wide range of different hardware types as well. Again, working very close to the metal, taking advantage of these hardware capabilities and rendering platforms with our C++ core. Really, the end result is that you get to pick the SDK that you need based upon your user environment, or the environment requirements that you have, or existing or planned skill sets that your team has. So this chart just shows a brief look of each of the SDKs down the left-hand side and translates to support for various different target devices along the top. So we'll just work down from the top here. So our Maps SDK for .NET, it's a cross-platform SDK. It's designed for desktop and mobile apps, primarily supporting Android, iOS, and Windows. It also supports macOS via Mac Catalyst, which enables you to compile for iPad apps for macOS. Our Flutter SDK, our newest native Maps SDK to the family. Again, cross-platform SDK for building maps that target iOS, Android, Windows, Linux, and macOS. Currently, we only support iOS and Android at this stage, but we're always interested in hearing from you about which platforms you'd like for us to support in the future. The next one is Kotlin. So Kotlin is an SDK for building mobile apps for Android, working with Android Studio. Qt is a cross-platform SDK for both desktop and mobile apps and provides really the widest range of platform support. Almost every platform that we target. And then Swift is an SDK for building mobile apps for iOS and iPadOS. Note it also supports macOS with Mac Catalyst, which enables you to compile iPad apps for macOS. Actually, the latest release added initial support for VisionOS in window mode. If you're looking for more information on that, we're going to have a little bit more detail on that, on the roadmap for that in our Road Ahead session on Thursday. So something to keep in mind. That's a relatively new platform that we're targeting today and looking to expand in the future. Now, if we want just a kind of an overview of the requirements for mobile and desktop development for our native Maps SDKs, really one of our guiding principles here is creating SDKs for you to build applications to really meet you where you are, so meet the developers where they are, right? And this is what we continue to strive for by building multiple SDKs that support languages and frameworks and tools that you and your colleagues want to use. So each of these SDKs has specific development languages and environments. Granted, in the case of Flutter and Kotlin, you can potentially use others. So if we just do a quick rundown here with .NET, our .NET Maps SDK, you're generally using C#, you're building in Visual Studio. With the Flutter Maps SDK, you're working with Dart. You're usually using Visual Studio Code, but you could use Android Studio as well if you're just developing apps for Android. With the Kotlin Maps SDK, you're working with the Kotlin language using Android Studio or maybe IntelliJ. the Qt Maps SDK, working with our C++ API, leveraging QML, and working with Qt Creator. And lastly, our Swift Maps SDK, working with Swift and Swift UI using Xcode to build that application. So just a kind of an overview of the languages and the IDEs that you'd use, depending upon which developer, which native Maps SDK you choose to use. Now with that in mind, I'm going to hand it off to Nick, and Nick is going to take us through some of the capabilities of our native Maps SDKs. Nick?
Excellent. Thanks, Rex. Yeah, so Rex gave an overview of the architecture of the SDKs and how we deliver them for different developer environments. I'm now going to change tack a little bit and look at some of the capabilities that we deliver through the SDKs. So let's start with the basics. The native SDKs support 2D and 3D apps. They deliver a UI component for each, and that component is what you add to your app to display and interact with 2D maps or scenes. Now, as Rex mentioned, the SDKs have rich offline capabilities. Pretty much everything you'll see on these next slides can work offline as well as online. We support working with local files and packages from a variety of sources and in a variety of formats, but also tie directly into capabilities that are built into the ArcGIS system for working with web maps and services while offline. That means workflows for downloading web maps, for viewing and editing offline, as well as workflows focused on individual services should you need that level of granularity. Now, the preferred approach is web maps because it can simplify your development, but both options are fully supported. An important component of mobile mapping applications running on phones and tablets is location. For that reason, we build location directly into the heart of the SDK. We provide a location display experience, we often call it the blue dot experience, directly in the map view. It can be driven by the on-device location hardware, but we also provide out-of-the-box integration with external NEMA sources as well as indoor location sources. And should you have a proprietary solution of your own, we provide an API for hooking your own location providers directly into our location display. But the location display drives more than just a blue dot on screen. It feeds into our geofencing solution, GeoTriggers, for example. It drives our navigation API for interactive voice guidance when driving, which you can see animated here on the slide. And it also drives floor-aware maps that you might author, allowing for things like automatic floor switching as you walk around a facility. Then we get to the data itself. We support viewing, editing, and querying data online and offline. When you edit data offline using WebGIS workflows, we also support seamless synchronization with the source services and web maps, allowing you to send your offline edits back to the service, as well as update your local on-device data with the latest edits from the service. You can also edit data in a variety of local file formats, including mobile geodatabases, OGC geopackages, and shapefiles, to create your own highly customized disconnected data editing workflows, enabling data collection and editing in apps that potentially never even see a network. You can also geocode and reverse geocode online and offline, and calculate routes, service areas, and closest facilities online and offline. And those routes can be used with the navigation API that we saw on the previous slide, and you guessed it, that works online and offline. Now, last but by no means least is the incorporation of a high-performance geometry engine directly in the SDKs. This allows you to manipulate geometries like cutting them, projecting them, or adding or removing points, etc., deriving geometries from other ones, for example, with a buffer or a union operation, and analyzing geometries, calculating distances between them or determining spatial relationships between them, all directly on the device for all sorts of highly responsive, interactive user experiences. Now, with those basics in place, let's talk a little bit about how the SDKs work with the ArcGIS system. They support our WebGIS patterns, working with web maps, web scenes, ArcGIS portals like ArcGIS Online and ArcGIS Enterprise, and ArcGIS data services and analysis services. They embrace our authentication and authorization models, whether you're using named users with OAuth or API keys. They support ArcGIS authentication integrations with third-party SAML and single sign-on solutions, and network-based authentication like PKI and IWA. And as I've already alluded to, this means that the SDKs work directly with ArcGIS Online and ArcGIS Enterprise, including their sharing models and user types, and with ArcGIS Location Platform. They also work with local packages generated by ArcGIS Pro, like mobile map packages, mobile scene packages, mobile geodatabases, and so on. Now, they also work closely with various other ArcGIS products and technologies, like utility networks and ArcGIS Indoors. In the last year, we rounded out our support for offline utility networks, allowing you to download a network, edit it offline, recalculate topology, and perform network traces, all offline, before synchronizing edits back with the source utility network service. And we have a rich real-time API, the Dynamic Entities API, that lets you as a developer really abstract away the management of streaming or real-time data and data updates. Simply hook the API up to a streaming data provider and we'll take care of matching updates to existing features on the map for you. We provide out-of-the-box support for a number of sources and an API to let you hook in whatever custom source you might have. As we'll see in the next two slides, we have extensive support for a large number of different layer types, whether they're vector or raster-based, editable, Esri-specific, OGC standards, or one of a number of other commonly used formats. And lastly, we have flexible licensing options. You can either license your app using named users, enabling different levels of capabilities depending on the user type that's using your app, or you can choose to license using license strings and not require your user to sign in at all. The option you choose will depend on the end user of your app, and you can even combine these approaches should you need to. So here's an overview of the layer types we support when connected to a network and able to access data services. As you can see, there's a range of services we can connect to, some read-only and some also editable. And we have great support for OGC services as well as ArcGIS services. Some of these, like the dynamic entity layer and the web tile layer, can even be customized to connect to proprietary endpoints as needed. And here are the layer types we can use while offline, based off either local files or packages. You'll notice a range of local raster formats, as well as support for electronic nautical charts and local 3D tile sets. In fact, by leveraging custom dynamic entity layer APIs I mentioned on the previous slide, you could even use dynamic entities while offline. Perhaps you're working with a proprietary isolated peer-to-peer mesh, receiving updates from nearby colleagues, but your app never connects to the internet. Okay, so let's take a look at some of these layer types, and I'll run through a quick demo of a few key types I want to highlight. This is using our Swift sample app, so you can play with all of these yourself. Let's start with an integrated mesh layer. Now here we see elevation and an integrated mesh I3S layer being loaded from a service. You can see the level of detail in here, but if we're able to see that layer load over the network here. Now the network here is pretty okay, but if you're working in with poor network connectivity or no network connectivity, you might want to load this from a file. So let's look at that exact same data loaded from a local file on my iPad here. You can see how much quicker that loaded. It's the exact same data. It's available as a scene layer package that I've sideloaded onto my device. And with the same bits of code, I'm able to access it and make it fully interactive on my screen. Along those lines, here's a point cloud layer with tens of millions of points collected around San Diego. We can interact with it, move around, pan around. I want to point out how responsive this is and how well this behaves with so many.
Stop display.
No,
there we go. We're good.
iPad. It is a bit touchy.
We're good.
Yeah. Let me know if it drops out again, please.
Okay.
Okay, so I'm able to interact with this. Tens of millions of points collected in the point cloud layer. Let's switch tack a little bit and look at a simple base map layer. Now the point I want to make here, this is a tiled layer. It's imagery. We can zoom in. We can see great detail in this imagery. And that's fantastic for an online scenario. But let's start to talk about offline layers. If we wanted to take a tiled layer offline, here's an example of that. This is what's called a TPK, a tile package. And as we zoom in, you can see there's a bit of detail there, but as we zoom in further, that detail starts to become lower resolution. The reason for that is, in order to have high levels of detail all the way in, you're creating many, many more, exponentially more tiles for each level of zoom in order to maintain that high fidelity. So one solution to that is vector tiles. Vector tiles render, here we're looking at a service, they render at the highest resolution of the device. And of course, all the labeling is rendered on the fly. So as we rotate it, the labels stay upright. But you can see we can zoom right in and still get all this very high fidelity of the data. One of the benefits of vector tiles is we can change the style on the fly here. So here we're just using our standard base maps and applying different styles to the same base map layer. And we can do that offline too. Here we're looking at a vector tile package of the area around DC. And we can zoom in and see the high level of detail here, all rendered at the highest resolution that the iPad supports. And again, I've got one tile package on the device, but I can apply different styles to it. So here I've downloaded different styles from our base maps, and I'm applying them to the same single set of tiles for this area around DC. We could also add a raster from a file. Here, I mentioned we have a support for a number of different raster types. This is a GeoTIFF on the device. Behind it is our global imagery service. But you can imagine you're in the field, you've sent up a drone, you've collected some new imagery. You can overlay that directly onto the backing imagery to get an updated view of the area around you. So with those local raster formats and collection techniques, you can bring them straight into the SDK. I mentioned we support OGC layers. Here's a WMS layer from NOAA of the current rain that's keeping us doused here. And we also support WMTS layers. We support API features, WFS layers as well. I've just selected a few OGC ones here. KML is an important one that we have great support for. Here we're looking at flights in Northern Europe. And a lot of KML use is in 3D, so we can zoom in and see these live updates. So this is a KML file with network links over to live updates, all brought in with just a couple of lines of code. The last thing I've got two more things to show. One is our global base map service. So this is bringing in 3D building data globally available that provides great context for your data in a 3D scene. We can change the way this is rendered. Here I'm adding an edge renderer to it, or based off the height of the buildings, we can do a class breaks renderer and render buildings according to their height. We take a look at New York here, jump over to London, pop over to Dubai. So this global set of base map layer tiles, base map data is available to you. You can bring it into your native SDKs. And the last thing I want to show is nautical charts. So here we've got a nautical chart. It's rendered on the device at the highest resolution of the device again. And we can do things like look at different levels of depth, for example, or for night vision, we can look at a dusk view or a nighttime styling of that directly on the device. Okay, with that, I'll hand it back to Rex to talk about licensing and deployment.
Great, thanks, Nick. So a great rundown there on some of the existing capabilities that we have in our native Maps SDKs. You can see we've spent years investing time and effort into building out these rich APIs and capabilities going forward. Now, of course, everyone's favorite topic, licensing and deployment, right? So once you start building with this, how to get it out the door, how to use it in production, right? So let's touch on this briefly. All right, so we'll start with deployment. So first thing to think about here is that once you've developed your application, now in developer mode with our native SDKs, generally everything is unlocked, right? You can use every capability, every functionality, access every data set, use every analytical tool. If you're in developer mode, you don't have to explicitly license anything. It just comes with the native SDKs when you download them at no cost. It just comes with basically a developer license, which allows you to access everything. You will get a watermark in your map and your scene. And if the IDE supports it, you might get a message that indicates that you're working with, let's say, a paid license level. What does that mean? Well, that'll come into effect when you look to take that application that you've built in developer mode and transition to production mode. You want to deploy that application to use it in production, right? So the first step there is to take a look at when you go to deployment is on the technical side of your development environment, right? So this is where you're packaging up the components that you need. You're actually licensing those. You're licensing the runtime or the native SDK using a runtime license to unlock functionality that's required for your application. Right? You might also be packaging up additional technical capabilities that you need, for example, a projection engine metadata, right? Or if you're working with local server, which we'll talk about towards the end of this, if you need to choose the parts that you need for local server deployment, right? So you need to figure out all the different technical binaries and pieces that you need before you deploy your application. Then on the business side, this is where it starts to get interesting, right? So First, you need to review the functionality that's being used in your application, and you need to select the appropriate license level and optional extensions, and we're going to cover those in more detail on the next slide. But a couple of different, and Nick alluded to this earlier, talking about working with named users and license strings, but there's two different options here for licensing your native Maps SDK. It's the same model, but two different options for licensing it. So the first one is a named user license, which means your native SDK is licensed with an ArcGIS identity. If that's part of the ArcGIS platform, it's part of ArcGIS Online, it might be part of ArcGIS Enterprise. So most named users include an ArcGIS runtime license level built in. And you have the option of choosing to use that when you're licensing native Maps SDK capabilities for production use. Now, the key thing to keep in mind is that that native Maps SDK license travels with that user, travels with that named user. So that user can unlock any number of native Maps SDK applications. Now, as a developer, you have to write code to be able to log into online platform or enterprise to be able to extract that information so that you can license your native Maps SDK. But that option, if available, will enable you to license any number of native Maps SDK-based applications. Now, the key here is that that license is only valid for 30 days, right? So you have to renew that license every 30 days. And at the same time, your users of your application need to have an ArcGIS identity right there too. So those are two critical factors if you choose to use the named user model for licensing your native Maps SDK. Now, alternatively, license string, so license string, or you might think of it as like a license key, means an explicit ArcGIS runtime license, right? ArcGIS runtime license to license your native Maps SDK. These are usually purchased in deployment packs. In general, the license string doesn't expire, and it's usually embedded within the native Maps SDK app itself, right? So each license is counted per deployment, which means per app, per device available to a single user. So if you have 3 native applications that you've built with a native Maps SDK, and you put all 3 apps on the same iOS device, which is used by one user at a time, that's 3 deployments, right? So the license string is a great option for those situations where users named users are not available for the app. So your users don't have a login, an ArcGIS identity to log in with, or that app needs to function offline for more than 30 days, maybe permanently offline. So that's another option. With that in mind, let's take a look at some of the license levels, and this is where capabilities factor in. There are 4 levels: light, basic, standard, and advanced. So first, let's take a look at light. So light is available to all developers at no cost. It includes viewing apps or viewing maps, scenes, ArcGIS layers of services, working with ArcGIS local data created by the ArcGIS system. This includes things like tile packages, vector tile packages, scene layer packages, mobile map packages, mobile scene packages, in many cases, mobile geodatabases. Now, depending on the package, these could be downloaded from ArcGIS Web Maps, they could be downloaded from services, they could be packaged with ArcGIS Pro. Light also includes a variety of analytical capabilities, such as routing and geocoding, both online and through services, and offline through, let's say, local networks or locators. So we consider light as basically our free level, right? So basic is our first paid license level. So basic includes everything in light, plus it provides an API to edit features and use the navigation API that's included with our SDK that you can build to build out a turn-by-turn solution. Now, I have to admit there are some exceptions. In general, we see the basic license level as if you're editing data or if you're using our navigation API, you license it basic. There are some exceptions. So for example, if you're working with data that you're editing that's from a feature layer that's hosted through location platform, that's available at light. If you're working with our route service that's available through location platform and you want to use a turn-by-turn direction with that route service, that's available at light, right? But a vast majority of those capabilities light up with our basic license level. Next level is standard, so this includes everything in basic, plus access to local data sources that are not part of the ArcGIS system. So what does that mean? Well, it means things like geo packages, shape files, KML files, raster files like geotiffs, Mr. Sat imagery. It also includes things like 3D visual analysis, the ability to do a line of sight or view shed in 3D or in a scene. In addition, local server is enabled. If you're working with local server, it's enabled at the standard license level. So the last level here, right now advanced, is really around, it includes everything in standard, but it primarily focuses on enhancements to local server today. That'll be advanced in the future, but today it's really about local server capabilities, and that means it enables access to enterprise geodatabases for editing, and also some advanced geoprocessing tools that local server exposes. Now, if we take a look at our extensions, we have an array of extensions. The first one is advanced editing. The advanced editing license enables a number of different advanced editing workflows. It's enabled with basic license level or higher. Generally, this is what's used when you're editing and updating a utility network, right, whether online or offline. StreetMap Premium delivers data and mobile map packages licensed by region. So this is really a data license, so the ability to view, geocode, and route against StreetMap Premium mobile map packages. So pre-prepared data, pre-provisioned data that you can use for a variety of purposes. And then the last extension here is analysis. And the analysis extension is only available at the standard and advanced license level. It includes native support for things like service area closest facility on a local network data set, but it also enhances support for local server to include things like 3D analyst, network analyst, and spatial analyst GP tools. So that's kind of a broad overview of our license levels and extensions, and really the model and the options that are available to license our native Maps SDKs. Now, that's just one aspect of an SDK. We want to take maybe a deeper look at the SDKs themselves. I'm just going to walk you through, what goes into the SDK. So really, this is really just more than an API, right? So it's not just a developer API that you work with in an IDE. We provide SDK resources that includes things like a comprehensive API reference, right? That gives you the ability to discover how the API functions and how it's used. A lot of times that's integrated within the IDE. We provide conceptual guides, right? That provide you with the ability to get started and really the steps that you need to take to be able to get started successfully. Where you need to download the SDK from, how you can get started moving forward, the different capabilities that you can take advantage of. And then, of course, a lot of times with our guide doc, we're going to provide you with what was made available in our release notes, system requirements. We're also going to have really conceptual ideas on how to work with maps and scenes and different operational capabilities. I'll also show you briefly here just a brief demo of how you can dive into some of the additional details about our licensing levels and options. We transition to tutorials. These are step-by-step tutorials that walk you through working with or getting up and running with our native Maps SDKs. A lot of times those solutions are available to download, so you can just download the solution pre-made and you can walk through it yourself. Samples explore and demonstrate the SDK, so they provide really a granular look at capabilities within the SDK. Many times the samples themselves are available. You can peruse them on our website. You can go to the source code. You can actually provide feedback in GitHub on the source code on GitHub. You can oftentimes download those apps as well, so you can start working with them even if you don't have a developer environment. Then we also include a set of toolkits, right? So the toolkits are really designed to enhance your usability of the SDKs. So there's core capabilities in our native SDKs that are delivered through our APIs, and then we enhance those APIs with toolkit components. Those toolkit components enable you to build these really visual UI components that are designed to enhance your mapping applications going forward. So there's an extensive array of those. Again, the source code is available on GitHub. You can provide feedback there. Many times our native SDKs have these toolkits available, pre-built, ready to use. And of course, there's a community and Esri tech support as well to help you along the way. So with that in mind, I want to take just a brief look. I'm just going to do a quick walkthrough here of our developer site. So this is developers.arcgis.com.
I'm not seeing your browser.
It's not showing in the browser? Oh, hold on, let's see what's happening here. Is that, can you try hitting it again?
Well, refresh this. I haven't switched it. So I think it's just on another screen.
Flick it over. Yeah.
You want a mirror?
Let's do this. All right, can we do that?
There we go.
Is that working? Okay, cool. We're good. Good stuff. Okay, great. So here's the Esri developer site, developers.arcgis.com. There's a lot of resources here, a lot of high-level guide docs, and then some detailed information based upon our Maps SDKs. And so I'm going to click on SDKs and APIs. In this case, I'm just going to go to our .NET SDK. We have a slew of Maps SDKs for web, native, and game engine. I'm going to click on the .NET SDK. Maps SDK and get started here. So we start with an overview page. This gives you kind of a quick getting started option here, so you can dive in right away and start working with the SDK. There's a couple of key things I want to highlight here. We'll take a look at the guide doc here in a moment, but at the top we have an API reference. This API reference is extensive, so you can go in, you can search. You actually get quite a lot of detailed information about classes, members, and other properties and capabilities. If we go back and take a look at what else is available, there's a set of tutorials that we mentioned that you can walk through. You can download the code associated with them. And then I mentioned sample code. So with sample code, we have a mechanism here that allows you to search sample code on the site. And so you can start looking at what that sample looks like in your browser. As a developer, you can go out to our GitHub repo and you can download our samples and start working with them there. And we also generally have the sort of precompiled, pre-built sample application that you can download. So in this case, this is the ArcGIS Maps SDK for .NET samples for WPF. If you go out to the Microsoft Store, you can download the app on your Windows device and you can start working with the app right away. Now another option here is working with our open source toolkit. And so our toolkit, again, there are components that you can download, but at the same time, you can work with the source code. You can pull the source code. You can manage the source code. You can actually change the source code. This is just a way for you to get started working with the different components that are available to really enhance your mapping application going forward. So a lot of opportunities there, certainly, to get started with our native SDKs and to kind of uplift the work that you need to do. Now, a couple things I'm going to highlight here within our guide doc, which is extensive and rich. Is system requirements, just to make sure that if you're working with a specific version, that the system requirements that you need in place to be able to do that, whether it's Visual Studio or the operating system that you're working with, or the deployment environments you need to target, are supported by our release. The latest release notes that provide you with details on what we just released. Extensive guide doc on capabilities. And then I'm just going to highlight this. There's a licensing and deployment section here. So if you're looking for more details on the options that you have for licensing when you go into production, and then also the different levels and capabilities, there's an extensive documentation here that's available for you to take advantage of that. One thing I will highlight too is there's a section here that talks about licensing by API. So we don't have a tool that goes through your code or combs your code to discover if you're using a specific level or an extension, but we do have a document that talks about the different operations, classes, and functions within the API that require a specific level, right? So if you want to know that I'm editing a feature and I'm adding an attachment, what level does that require? Well, I can look in my document here that gives me basically anything that requires more than light is going to be listed here. Right, so I know at this stage that if I'm going to call that method, I may need a basic license, right, to be able to do that in production. Right, so there's an extensive doc here that allows you to peruse the different operations that you may or may not be taking advantage of within your code. Last thing I want to highlight here is resources. So I mentioned, obviously this is the developers at ArcGIS.com, the Esri developer site. Sample code there's a resources section here within the guide doc. It'll take you right to our sample code. It'll take you right to the toolkit. It'll take you to our developer community. And that developer community is a great place to get answers. So there's an extensive community out there. We're very active. The development team is very active on this community board as well. So a great place to go if you need answers to your questions. Great. And with that, I'm going to hand it back to Nick, and he's going to cover what's new.
Okay. Thanks, Rex. Yeah, so let's take a look at some of the highlights of what we've added in the last year to the native SDKs. The first two items you see here, feature forms and the geometry editor, serve to improve our feature editing experience via the SDKs. Features are made up of a geometry and attributes, and providing great tools to work with these is key to making your life easier as developers. We'll look at some of these enhancements in a demo in a moment. We've also been working on enhancing our 3D support with support for OGC 3D tiles, both from services and local packages. We've added coordinate grids in 3D, you can see demonstrated here. We've also made some enhancements to our KML support, which, while not strictly 3D, is almost always surfaced in a 3D context, specifically improving support for custom attributes and KML tracks. One of the major achievements in the last year, that, as I already mentioned, as you saw in the plenary today, was offline utility network support. We now have the holy grail of being able to download a utility network, keep the offline version up to date by synchronizing deltas, being able to edit that offline utility network, including connectivity and rebuilding the network directly on the device, And finally, also synchronizing offline edits back to the source service. We've also updated some of our military symbology support. We've refined geotriggers to handle geofence geometry updates. So whether those come from auto-refreshing feature layers or actual edits to geofence geometries, the correct geotriggers events will now be fired. Another major achievement, which I'll talk about more in a moment, is the introduction of a brand new Flutter SDK, allowing you to build ArcGIS apps for Android and iOS devices. And we've seen initial support for Vision Pro through the Swift SDK, allowing for a Vision OS windowed view of your ArcGIS app. Essentially, it's like holding up an enormous iPad in front of you in your virtual space. Lastly, in the last year, we deprecated the ArcGIS Maps SDK for Java, with 206 being the last release of that SDK. So over the years, Java's proven to be not the ideal technology for building user-facing apps. It has great strengths, user-facing apps, not so much, especially when compared with some of our other SDKs. So let's jump into a demo, and I'm going to show some of those field editing enhancements in action, assuming my iPad appears. Excellent. Okay, so here we're looking at a utility network, and I'm going to add a new service line to it. Now, the blue dot on screen here kind of represents my finger. As you can see, like it obscures quite a bit of the screen. And imagine I'm in the field wearing gloves, that's going to be even bigger. And so trying to place a precise geometry is very difficult. Even with snapping on here, I'm not sure that I'm actually placing it where I need to. Precise geometry positioning is important for utility networks because it derives connectivity based off that. But there are countless other geometry collection use cases where precision is important. So to deal with that, in the last year, we added a reticle experience. Now, this is a fixed crosshair in the middle of the map. You can alter the appearance of this, but you can see my finger is now out of the way. And I'm able to move the map around and very clearly see when I'm snapping to the equipment that I want to snap to. So this is transformative for working in the field, especially if you're on a moving vehicle or something, or you're wearing gloves, being able to precisely position geometry. And if you're working in an environment where you can't see the screen too well, perhaps it's bright sunlight, we've also introduced haptics, so you can actually feel when that snap happens. So that's geometry editing. Now let's take a look at some of the enhancements to the attribution editing. Now here I've popped up a feature form. Feature forms are smart forms. They're configured by the Web Maps author, and they can take advantage of schema definitions plus additional configuration that the Web Map author provides to guide you through collection of data. Perhaps it hides certain fields that aren't important when you're going down certain paths, or it can pre-calculate values. Now here we're looking at a simple feature form. I've set the service line type to residential service, but you can see it's still asking me for more information here. And again, any information that I have to pick in the field manually is an opportunity for data corruption, data errors, and inefficiency. So what I'm going to do, I'm going to take advantage of the feature form's barcode scanner. You can imagine this barcode is on the pipe itself. I'm trying to be very careful not to lose the picture here. But we were able to take that barcode scan, and encoded in that scan is information about this service line that we just added. So I've been able to add the diameter and material without having to pick from those pick lists. Now this is a very simple example. You can imagine if you had 10, 15 attributes that you need to add, this is a huge time saver and reduces errors. Now we can take a look here really quickly and do a quick trace on here to show that we were able to properly connect that new service line, and when we zoom back in, you can see the trace was able to follow that new service line. Now, incidentally, all of this is done offline on a utility network that's been downloaded to my device. Granted, yes, I'm on Wi-Fi. You'll have to trust me that this is a completely disconnected example that I've just shown you here. And what you've seen here as well, we saw the feature forms. That's a toolkit component. The trace tool here that we're looking at is also a toolkit component, open source, available to you. So let's take a quick look at some of how this is done in code. So the geometry editor, all we do is we create a single geometry editor, and then we set it on the map view. We tell map view to use that geometry editor. Then when it comes time to actually use it to create that geometry, we set the geometry editor tool. I started off with a simple vertex tool, but then we switched over to the reticle vertex tool, And that's all we had to do to get that completely different, enhanced editing experience. Snapping was on for both cases. And then you start the edit by passing in our case, we set a new geometry type because we're creating a new geometry. That could be point, line, polygon. If you've got an existing geometry you want to edit, you've got a start method that just takes that geometry, and you get that full editing experience there. For the feature forms that were configured in the web map that was downloaded, it's pretty simple as well. We create a feature form passing in the feature that we're editing. That code goes into all that configuration and populates that model for the user interface for that fully interactive experience. And that interactive experience is brought to life with this feature form view. That's the toolkit component that you get from the open source toolkit, and you pass in that feature form model definition. So the final thing I want to show, just quickly, if I can get to it, is 3D tile support. So here we're looking at, again, our 3D base maps. We're looking at Boston here. This is our 3D buildings layer. But I happen to have a OGC 3D tiles layer that provides a lot more detail. We can zoom in here and see some of the detail that's provided in this layer. My point that I want to make, though, is that this is not just a visual thing. This is a full participant in the scene. I've just done an interactive view shed based off the camera location. We can zoom out and we can see how that 3D tiles layer fully participates in that view shed calculation. As we swap it out for the 3D base maps, you can see how that changes. And we can zoom into an area here. We're not pulling the trees in from our 3D base maps layer for the purposes of this demo. And I can turn it on. You can see the additional detail that's brought in from that 3D tiles layer, fully participating in the scene alongside all the other data types. Okay, let's switch back and talk briefly about Flutter. So Flutter is a completely new SDK that we introduced in December. It allows you to build apps for iOS and Android. The SDK came about in rapid time with our shared C++ core and the tooling we've built over the years, meaning we could build a proof of concept, deliver 2 public betas, and roll out the SDK in about 18 months. The SDK, the beta showed that people wanted to use the SDK. And in a classic sort of pick 2 out of 3 problem, we had to balance capabilities, quality, and getting the SDK in people's hands quickly. So we decided to release capabilities over time. Mind you, we still delivered a lot in the initial release. You can see the subset of capabilities here. And that beta allowed us to be comfortable that this was a useful set of capabilities. So you can do 2D viewing and editing, online and offline. We support most of the major layer types. There's a few exceptions. Obviously, the 3D ones we won't support since we don't support 3D yet. We support geocoding and routing, online and offline, user authentication through OAuth and API keys. Now, there's still a lot to come. It'll take several releases before we have everything available to you. But you can keep track of our plans on the developer site. We've created a dedicated page that we update with each release that openly talks about our plans for rolling out the remainder of the functionality. For example, in our next release coming in a few weeks, we'll be introducing full raster support and rounding out our location support. Right now we have a blue dot. We're going to provide off-device blue dot support like NEMA devices. We'll introduce full support for geotriggers as well. We'll have that navigation API up and running. So let's take a quick look at what Flutter looks like in practice. Now I'll swap out here. Let's just hide that. Okay, so this is a very simple Flutter app. First thing we do is import the Flutter package, ArcGIS_maps. Now we use pub.dev as the Flutter package manager. We can import it there, but you can also download it if you're working in an air-gapped environment. We set an API key so that we can use some location platform services. And then we build an app. Let's take a look at what that app looks like. We begin with that map view. I mentioned a control that we provide. Here it is, the ArcGIS map view. You drop it into your Flutter app. Now, Flutter applications are comprised of widgets. Widgets arranged around each other, on top of each other in a hierarchy. We provide that ArcGIS map view. We set it up with a simple map using our OSM Streets base map, and we set an initial viewpoint. And then we've got some overlay controls. Now, those overlay controls are defined down here, but before I dig into those, let's take a look at them in action. So here on the left-hand side is the iOS simulator, and on the right-hand side, an Android emulator. These are live apps. They're focused on DC at the moment. We can zoom into the convention center there, for example, but they're fully interactive. Now, I want to change the layout of these icons. I'm not particularly happy with it. I want to wrap them in a row horizontally. And you can see in this fully interactive live application, that user interface just updated. I didn't have to rebuild the application. This is a feature of Flutter called Hot Reload. It's incredibly useful for experimenting with your user interface, updating it on the fly. I'm just moving these buttons to the bottom of the screen and the center of the screen as I talk. But they're still fully interactive. In fact, I can click this button here and get a set of directions from that convention center in DC to 6 locations around the city. And again, on the Android side, you can do the same thing. Now, Hot Reload doesn't just limit itself to the user interface. Let's talk quickly about how we do that route, just to show some more sample Flutter code from the SDK in practice. Here, we're just creating a route task pointing it at our global route service, set some parameters, including the starting point and a bunch of stops around DC, and then we call route task solve. That gives us back some geometries. We created some graphics and we put them on the map. I can change how that route is calculated. Let's get the results in the best order rather than the order that I provide them. So I can recalculate that now, and you can see the result is different just based off setting that value. So that hot reload didn't just apply to user interfaces, it also applied to the ArcGIS code that we have in there as well. So Flutter is a really powerful way to interactively and quickly build yourself iOS and Android applications. Let's jump back to the slides. I guess we'll hand over to Rex for local server.
Good stuff. Good deal.
Good.
All right, great. Thanks, Nick. Love the live demos there. The quick barcode scan. Things are working fine. That's good. Mm-hmm. Proof of concept. So local server, we're just going to take it in a couple more slides here. We'll talk a brief bit about local server, and I want to highlight the fact that we've deprecated local server. So this local server deprecation was just announced. The last release will be later this year, so right now Q3, which will be our 200.8 release. Again, if you're looking at a road ahead, like what our road ahead plans are, please come to our session on Thursday, late afternoon, evening, for more details on this. But the key here is that local server is going to be retiring in about 5 years, right? So we're looking at 2030 for its retirement. It's an LTS release, which means we get 5 years of support. That's 2 years of general availability, 1 year of extended, and 2 years of mature. So for those 2 years of general availability, we're going to handle things like if we need to deliver patches, we'll evaluate if patches or hotfixes or anything needs to be delivered in that time frame. With that in mind, let's talk a little bit about local server itself, right? What are the options? So local server was introduced over 15 years ago to provide a mechanism for native application developers to access the rich depth and capabilities of ArcObjects on desktops, so Windows and Linux. And so local server was a mechanism for doing that. At the time, we started our new native SDKs called our runtime SDKs, and that was back in 2011, 2012. And so this was a way to fill some of the gaps that we had with functionality by leveraging ArcObjects. So over that time, or since that time, we've started filling in those capabilities within our native implementation, within our native SDKs. And that includes things like being able to access raster data directly, working with shape files, leveraging a geometry engine to do things like buffer and reproject. Those are capabilities that are natively available within our native Maps SDKs today. There are some things that we don't support, for example, access to a file geodatabase. But we have other options that allow for you to be able to build out or deliver a geodatabase that works cross-platform, and that means that being able to view and edit in a mobile geodatabase, something that can be created by a SQL-enabled feature service or by ArcGIS Pro today, that enables those offline workflows. We also have packaging capabilities that allow for you to take map data, put it in a mobile map package or even a mobile scene package and deliver that for use within our native SDKs. We are looking at closing some of those gaps that we have with local server over the next couple of years, leading us into its retirement in 2030. And that includes development around support for direct connect to enterprise geodatabases on desktop platforms, as well as enhancing our spatial analysis tools. There are really three key things that local server is used for. It's being able to work with file geodatabases and enterprise geodatabases directly, hosting map and feature services that enable access to additional data sources, especially raster data sources, and also really a geoprocessing server, right? So the extensive array of hundreds of different geoprocessing capabilities that are available through local server today. We're looking to close that gap over that time. But we do need feedback, actually, from you guys as to what would be necessary. Now, we did have an announcement on this, a blog post. We did have a deprecation notice. It does provide some migration options there for you to kind of get a heads up on how to move from local server to a modern developer technology that we're going to be promoting or supporting into the future. But feel free to reach out to us, either your account manager. We have an email address here, an alias that you can send questions to if there's an issue that comes up. I'm actually curious, is anybody using local server here? Oh, there we go. Local server right in the front. Good stuff. Anyone else? One? Okay, good stuff. All right, so it sounds like we might have a conversation here at some point, so good stuff. With that in mind, this is the last slide, and it's really about related sessions. We're just kicking off this week at the Dev Summit. There's a lot of sessions here around native maps SDKs, depending upon what you're interested in. It could be specific SDK capabilities, like you want to learn more about the Flutter SDK or the .NET SDK or Qt or Swift or Kotlin. We've got sessions that enable you to showcase what it takes to build apps as well as advanced workflows. We have capability sessions that focus on things like rendering and utility network. We have a set of demo theaters that focus on very specific capabilities like building out AR workflows with Swift. And then user sessions. We have user sessions here that really showcase where some of our users are successfully building out native Maps SDK applications by building out their own synchronization framework, right? Or building out workflows or providing tips and tricks on how to work with our native SDKs as they've progressed through their solution. I will highlight the road ahead is on Thursday, this Thursday at 5:30 in this same room. So if you're here at 5:30 right before the party, this is a great way to kick off the party. It's 5:30, so I don't know, they might be serving drinks by then. So that could make for a pretty good road ahead. We'll see what happens, right? So I'm hoping that's the case. We'll find out, right? So with that in mind, that's our presentation. We'll go to questions next, but thanks for joining us. I know we went a little bit over. Hopefully that was content rich. Actually there too, so cool. With that in mind, we have a few minutes for questions, but I did have some questions for you, actually. Who's actually working with a native or a runtime Maps SDK today? Okay, a lot of folks. Who's using .NET? Working with .NET? Okay, that's a lot. How about Qt? Any Qt folks? Okay, there we go. All right, nice, there we go. Anyone Kotlin? Or Android? Kotlin or Android? Okay. Swift or iOS? Okay, good stuff. Anyone work with Flutter? Anyone using Flutter? Anyone actually who doesn't use a native SDK today who's thinking about it? Right here. Okay, good stuff. All right, there we go. Opportunity. That's what I say right there. Nice. Good stuff. And with that, we've got a few minutes. Any questions that you guys have? Feel free to ask. Otherwise, we can meet up with you guys after this session. We can talk it through. So, question right in the front here. Yep.
Do you have any updates on Java, or is that on the road ahead?
We will talk about Java on the road ahead. Because it has been deprecated. So we'll talk about the deprecation timeline, and we'll even touch on some of the migration options there too. Yeah, so no further plans to release a Java SDK at this point. 200.6, which is the current release, is the last release. Yep. Cool. Yep.
Does the road ahead include expansions on the OGC 3D tile support? Like, are you guys going to support more than just mesh, or is there any sort of inherent LAS support coming?
Ooh. So a question there on additional support for 3D tile capabilities. So generally within Esri, we intend to support everything we can with respect to 3D tiles. We won't talk about that specifically in the road ahead, but that's great feedback, actually, for us to focus on. We do intend to support more than just mesh. That is the goal. We only support mesh, right?
Great. And then any plans for direct LAS support in the .NET Maps SDK like you do in ArcGIS Pro?
Not at this time. Not at this time, but good feedback as well, right? we have a bevy of other sort of data sources we need to support directly as well. For example, ArcGIS Pro supports hundreds of raster formats. We support 20 actually within our native SDKs. So we need to expand that for sure as well. So there's definitely room there for expansion. Keep in mind though that if we add support for something like that, it'll be licensed probably at a minimum standard license level, right? So it's a paid license level, just to keep in mind.
I would take a compromise for SLPs not to be read-only and to be edited.
Editable SLPKs. Okay, it'd be interesting to talk a little more about what you're looking to edit within the SLPK. So that's good. It's an array of feedback. I love it. In the back there, is that Jeff? Is that Jeff Archer? Oh. Good. What's happening?
Yeah, in one of the demos you showed using vector tiles.
Mm-hmm.
And I'm wondering if there's, maybe it's been released recently, but to my knowledge, you can't do like the same thing you can do in JavaScript, where you can do a hit test to identify on vector tiles, but there are plans to include that in the SDK in the future.
Fantastic question, Jeff. So are we planning to add intelligence to our vector tiles implementation to support identify, right? To be able to get attributes out of the vector tiles? The short answer to that is yes. That's a longer path. We've got some work to do with our vector tile support that we'd like to be able to enhance going forward to support things like multi-source vector tiles. But we've got work to do in that space. We fully intend to support identify. Probably not something that will land this year. Side note, probably earliest to be next year. So, but we fully intend to support that. Yep. All right, question here?
For the offline UN, that's a basic license with a UN extension.
So being able to read and visualize utility networks is supported at Lite. Now, the ability to edit or validate a utility network will require an advanced editing extension. Now, the advanced editing extension requires basic at a minimum, right? So at Lite, you can view and visualize and interrogate a utility network. To be able to edit and validate a utility network requires advanced editing with a basic license. Now,
You can also trace at Lite.
You can trace at Lite too. Yeah, you can trace at Lite too.
Downloading a UN without UN capability.
That would be, so from a licensing level, a native SDK licensing perspective, you can download the UN at the Lite license level. It's just the operations that are available once you have that utility network, which may require an additional level or extension there too. So I guess the key there too is, one of the other keys there is that we have two different options for our license model, right? So you can use the deployment packs with the license strings, but if you already have named users, and those named users have the appropriate type, and they have the appropriate user type extension. So for example, if you need a named user that comes with a basic license level, you're going to need to work with I think it's a field worker. Is that right? I think it's the field worker level. It might be creator. No, creator's standard, but I think it's mobile worker. I think mobile worker is it, right? So so mobile worker is it comes with a basic license level, and then you also need the advanced editing user type extension on top of that, right? Associated with that user. So those will enable you to unlock that functionality in our native SDK. Now keep in mind, all we're doing here is unlocking the API. We're not guaranteeing it works actually on the server, right? So we're unlocking the API so you as a developer can make the call in the API. You might still need some level of authentication to be able to do that on the server side, right? So we're really just talking about unlocking the API on the native SDK side. So, yeah, good stuff. Question?
The demo that you gave with UC's network where you did editing,
Yep.
And you were disconnected, the trust of you. The question I have is, so you were disconnected, you did editing, you did validate locally,
Mhm.
and you trace locally as well. So
Right.
Yes.
that you had to send back in order to be able to.
We didn't.
That's
Yeah,
correct.
That's correct. Yeah, we can validate and we can then trace. So we can accommodate for those dirty areas through validation purely on the client, purely through logic that we're delivering through our native SDK purely offline, right? So in order for us to do that though, to call that API, to be able to make that edit and that validate call, we need to make sure that the app in production is licensed at basic with the advanced editing extension, right? If you're using a named user that has those licenses available, that app will work offline for up to 30 days, right? If you needed a license string, it'll work in perpetuity, basically. So, but that call that we made there to edit and validate, there was a license check in production to make sure that worked. Now, granted, if you're in developer mode, right, that'll all just work. But you'll see a watermark on the map to indicate it's in developer mode, right? So that's the one aspect I talked about where you have to think about, when you go from development into production, what license levels are you going to need to be able to take advantage of those operational capabilities. And so that API, that license API, documentation is pretty critical. Anything that's not in light is going to be in that document. So if you're trying to figure out, if there's a method call on a specific class that requires a certain license level, use that doc, right? We don't have a tool that combs your code to do that, right? So you'll have to look at the doc to evaluate what you're making a call, what calls you're making to determine what license level and extensions you're going to need. So hopefully that helps. Yep.
Have you guys started talking with the roads and highways team?
With which one? Roads and highways?
Yeah, roads and highways. Incorporate that in the SDK.
Incorporate roads and highways in the SDK? Are you thinking? Are you talking about through StreetMap Premium or a different mechanism?
LRS and using service, be able to go offline, online, and being able to handle that on the code side while the thing, instead of having to build it all around that.
Oh, interesting. I'm not familiar with something specific on the roads and highways offering at this stage. Although, depending upon how it's served or how it's hosted, there might be a mechanism on the services that are hosting roads and highways to be able to take that data offline.
Yeah, it's much like a utility network where
Okay.
logic is built in, service calls, but
Okay. So there could be maybe two approaches. I'm not quite sure, but it could be something where with sync-enabled feature services, you do have a download-only option, right? So you're not editing the data, but you're actually taking that data offline. So there's that option, which is usually on demand. There's this other pre-planned approach where you've already got, let's say, specific pre-planned areas that you want to take offline. That might be, for all practical purposes, like a mobile map package, right? Because you've got diverse data sets within the same package. And then it's optimized for being able to pull it offline without having to generate it on the fly. So I'm not sure what roads and highways is offering. I'd have to dig in. Is there a specific person or team that you're working with at Esri on that?
roads and highways is pretty much in the professional services side, but
Okay.
they're having to build their own stuff right now, so we talked about that. But
Okay. But you have a use case where you need to be able to use it offline. Okay. Do you need to be able to clip out areas that you need, or is it just, are these sort of predefined?
events and that kind of thing.
Okay.
Or even the ability even to change some routes.
Okay. Okay, that's a little different. A little different. Okay.
I mean, that could be a possibility in the future, but yeah,
Okay.
that's
So one thing that has come up recently is because we have the ability to work with utility networks online and offline, and we can actually change utility networks on the client, and we can update those changes on the server, or change the utility network on the client and then actually rerun analysis like a trace and have it honor those changes. There's been a sort of a complementary request about, well, what about transportation networks? Can I take a transportation network offline, make changes, sort of validate the network so that all the connectivity is maintained, the topology is there. We don't have that capability yet, but it's a completely valid request if there's a real need for that to work offline. So because we've got a model for it with utility network, I think it's probably tenable for transportation networks too. So that's a good question. Yeah. Cool, good stuff. All right, guys, I know we're a little over, but thanks for sticking around, and hopefully that was useful. Looking forward to talking to you the rest of the event here. If we can meet up. If you have any questions, feel free to come up and ask. Thanks again, guys. Have a great rest of the conference.
Thank you, sir.